Okay, right. Now, the next part of the question, which is still a continuation from the first one, they say that if the malware program continues to act indefinitely, meaning infinitely, what fraction of the user screen will eventually be blocked out? Now, for us to be able to do that, now remember, um, in the in the previous question, we've got that for the first day, it was 1,000/3 units squared, and for the second day, we found it to be 4,000/9 units squared, and then for the third day, we found out that it was 16,000/27 units squared, right? Now we can take these as a sequence or as a series, but for this case, they say that it continues indefinitely. So what they basically looking for, they want us, now remember, listen to the English here. They say that if the malware program continues to act indefinitely, indefinitely is basically meaning infinitely, infinitely, right? Now they say that what fraction of the user screen will eventually be blocked out. Now I want you to look at this. This kind of a series, it's actually a geometric series. So if we basically look at this question, this we are dealing with a geometric series, right? This is a geometric series or sequence. Now remember, we have that a is equals to 1,000/3, right? And then remember, from the properties of a geometric series or sequence, r, we can determine it by say r equals to t2 over t1. And then looking at that, our t2 is 4,000 over 9, and that is all over 1,000/3. And then if we do to our maths, we're going to basically say 4,000/9 multiplied by the reciprocal of 3 over 1,000. And if we do that in a calculator, so it's 4,000/9 times 3 over 1,000. You should get 4/3. Now, if you put 4/3 in a calculator, can you see that 4/3, so 4/3 is actually bigger than 1. So can you see that therefore r is greater than 1? Now remember, for us to ever calculate whatever, so what they mean is the fraction, so whatever to calculate the sum to infinity of a geometric sequence, remember, we always need different color for us to use the sum to infinity, right? Our r has always, so is supposed to be always be between -1 and 1, but can you see that 1 is bigger than 1? And then if the sum, if our ratio of r is between -1 and r, it means that it converges, right? And then immediately if it converges, then basically we're going to use that formula s infinity equals to a over 1 minus r, right? Then we're going to get the fraction of the user screen that is eventually being blocked out. But in this case, we don't have that. Our r is bigger than r. So basically, if our r is bigger than -1, and if our r is bigger than -1 and also bigger than 1 is, or either is not between -1 and 1, it means that our sequence, ne, our infinite geometric series will diverge, right? Because it's no longer converging. Because remember, if it converged, then we were going to just use that formula and then sub in a, which is that, our r, which is that, and then we were going to get a fraction. But seeing that our r is bigger than 1, it means that our infinite geometric series will diverge. And now remember, in according to the properties of a geometric series, if it doesn't converge, it's going to diverge. If it doesn't diverge, it's going to converge, right? Then if it diverges, this means that eventually the whole screen will be blocked out. So in this case, we're not gonna have a number. If our sum to infinity was converging, then we were going to have a number. But in this case, seeing that our value of r is bigger than 1, it's not gonna diverge. It's not gonna we're not gonna basically have a number. It's basically the whole screen is gonna be blocked out. But if it was converging, then we're gonna have a certain number, probably maybe like 50 over something or something there around. But seeing that our sequence or our series is diverging, the whole screen is gonna be blacked out. All right, I hope that you understand the difference between converging and diverging regarding sum to infinity of a geometric series. Okay.